Good evening everyone. So today we are going to see about the process capability and performance indices, that is CP, CPK and PP, PPK, how to understand these things and how to apply these indices for a pharmaceutical product in order to evaluate the process capability. And also let's see the correlation between the CP, CPK, PP, PPK as well as the sigma level. So usually we will be mentioning the process robustness in terms of sigma level, like it's a 3 sigma, 4 sigma, 5 sigma or 6 sigma. And usually as a continuous improvement engineer, we will try hard to increase the sigma level of a process so that the reproducibility of the process is going to increase. But how to evaluate it statistically and how to interpret these indices? So how to correlate the sigma level to these indices? So that we are going to see in today's session. So first of all, let's try to understand what these indices means. CP, CPK, PP and PPK. So these CP, CPK are going to be one set and PP, PPK is going to form a second set. So usually we'll be mentioning this CP, CPK as short-term capability and coming to this PP, PPK, we are going to mention this as long-term performance. So there is a difference between capability and performance. So capability is going to be something which we are going to do, like the ability to complete a specific task. So this we are going to mention like it's as a future case, like we got some ability and we are going to mention that, so we got this ability to complete a task, but it is not going to be mentioned depending upon the current or the past things. While coming to the performance, so performance is something different. Why? Because performance is going to be defined based on the tasks that we have completed and how good we have done or how bad we have done, and depending upon that we are going to define this performance. So CPCPK, it refers to short-term capability, and PPPPK, it refers to the long-term performance. So what is the difference here? So that we have seen like the actual difference between capability and performance, but when to choose this CPCPK and when to choose this PPPPK, this we need to see. And also what does exactly this CP and PP means and what does exactly the CPK and PPK means. So this also we have to understand. So basically CP, we are going to mention this as a capability index, and coming to this CPK, it is centering capability index. So similarly coming to this PP, this is going to be performance index, and coming to PPK, this is going to be performance centering index. This is how we are going to say, and let's try to understand each thing individually so that it is going to be easy for us to remember. Though these two are going to be of different versions, but the similarities are going to be CP as well as PP are going to be having a common similarity, and and simultaneously the CPK and PPK will be having a close connection. So these two is going to be having some similarity and these two is going to have some similarity. So whenever we want to analyze the capability index or performance index, so it is going to be defined as how well the data points are going to be fitted within the specification limits. So let's take an example to understand this better. So we got a specific product. So product ABC, I'll take it. And for this product ABC, before starting of development, we got certain requirement from customer with respect to specification. So we got a specification from customer and this is his requirement. So we will be mentioning the specifications as the voice of customers. Why? Because these are being laid by the customer. And coming to the second thing, it is nothing but a voice of process. Means how the process is behaving and what type of output the process is giving. So it is nothing but a voice of process. Let's say we got a yield, and for this yield we got a specification of 70 to 120 kgs. So this is a yield range. So this we'll be mentioning it as the voice of customer. Why? Because it's a specification. And coming to the next thing, so the average yield is going to vary between 80 to 95 kg. So this is the voice of process. Why? Because we are going to see how the process is behaving and how the process is going to give its output. So this is going to be led by the customer. So it's a voice of customer, and this is going to be the output of a process. So this is going to be the voice of process. And coming to this CP and PP. So CP and PP will help us to understand how the data points are going to be located, or how well the data points are placed within the specification limits. So I'll take a graph here. So let's say this is our x-axis. So let's say this is the axis, and on x-axis we are going to plot the yields. Okay, 70 to 120, this is the yield range, and I have plotted these yields on the x-axis. Okay, and these are going to be the specification limits. So where exactly we want to get? So this is the lower specification limit, and this is the upper specification limit. So ideally what happens is we have to get the yields within these ranges, the LSL, and this is the USL. So we have to get the data points within this range. And now let's see the distribution of the data. So let's say this is how the data has been distributed. So this is nothing but a classes, and on the y-axis, let's say it's the frequency. Frequency means how many data points are being available in these classes. Okay, so the data distribution is being shown like this. That means all the data points are available within the specification limits. So the CP and PP values are going to be high, like these values are going to increase. If, for example, if this same distribution is going to be crossing the specification limits, so let's write 1 minute. Now see, now in this case what you can see is these are the specification limits, and the data points has crossed the specification limits. So this is the accepted region. So this is the region where the batches are accepted. Okay, and apart from this, like whatever data points which are being crossing these specification limits, either on the lower side or on the higher side, so these we are going to mention as the rejected pieces. Why? Because these are not complying with the specification limits. These are not complying with the voice of customer. So these are nothing but a rejected pieces. So this is the accepted region and this is the rejected region, both on the lower side as well as the higher side. So CP and PP will help us to understand how many data points or how well the data points are lying within the specification limits. So CP and PPK will help us to understand how well the data points are lying within the specification limits. But while coming to CPK and PPK, So these things will help us to understand how well the data points are centered. Okay, that means, so if the here in this case the spread is high, in this case the spread is going to be high, but if the spread is reduced, that means if the data centering is increased like this. So I got an example here. Now see this. So this is the spread and these are the specification limits. So here in this case, if you are able to see, this is going to be the accepted region and this is going to be the rejected pieces, the rejected region. And in this case, the spread is extended beyond the specification limits and also the centering is low. And coming to here, so there are all even in this process also there are few rejected pieces, but these are going to be very few compared to here. And also if you are able to see here, the centering is increased. That means the data points are located centrally and the centering is somewhat better compared to this. And coming to here, there are no rejected pieces and also the centering is very good. While coming to this, the centering is very good and also there are no rejected pieces. So CPK or PPK will help us to understand about the centering of the data. So CP and PP will help us to understand whether all the data points are lying within the range or not. Range in the sense the specification limits. But while coming to CPK and PPK, this will help us to understand how well the data points are centered. Okay. Now let's see how to plot this graph. So I got certain data here. So total 30 batches of data I got. And for this 30 batches of data, we are going to plot. And just remember one thing, whenever you are going to do any statistical analysis, the minimum data points required is 30. Why? Because if the data points are going to be less than that of 30, automatically what will happen is there can be some impact of the outliers. So outlier in the sense there will be some data points which are from or which are of out of trends, and these outliers will shuffle or it will try to vary the standard deviation. So depending on that, you are going to get some wrong results. So just remember, whenever you want to perform any statistical analysis, you should get minimum 30 number of data points. Okay, and now let's see how to plot a graph or the histogram from here. So get into this, and here you got a histogram. Just click on this. So automatically the data will be selected and you will be getting a chart. So this is how a histogram is look like. And if you want to get this type of curves, so what you have to do is, so just try to connect the center point of these bar charts. So just try to connect the center points of these bar charts, and from this you will be getting this type of curves. So for the data that we got, so this is the curve. So this is how we got. So this is how we have to plot a histogram, and we can get this type of bell-shaped curves for the data. And one more thing that I have missed to add about this CP-CPK and PP-PPK is like when to use this CP-CPK and PP-PPK. There will be certain condition. So the condition is whenever you want to comment on the process capability depending upon the sample of data that you have collected, then you should use the CP-CPK for sample of data. So use CP and CPK. But while coming to this PP-PPK for population data, so use PP and PPK. This is for the sample and this is for the population. So there will be certain advantages and disadvantages for this two things. Why? Because whenever you are going to analyze the process capability using CP-CPK, so the advantages are going to be, it will be easy for analyzing. Why? Because you are going to collect only sample data. As you are going to collect only limited number of data points, the analysis can be done easily. But while coming to results, we'll mention here analysis and results. CP, CPK, PP, PPK. So analysis is going to be easy. Why? Because you got only limited number of data points. But while coming to results, so this is going to be, so we cannot comment exactly. Why? Because there can be certain variations. So results are going to be approximate. So these are not accurate. But while coming to this PPPPK, so the analysis is going to be difficult. Why? Because you have to handle multiple data points. And coming to the results, this is going to be accurate. Why? Because you are going to collect all the data points, and depending upon all the data points, you are going to define the process performance. So this is going to be accurate. But while coming to this is going to be approximate. But while coming to analysis, this is going to be easy for CPCPK. And here it is going to be difficult. Why? Because you have to handle multiple data points. Okay, so this is how, and this is how you want to select these indices, like depending upon the condition. And let's do one thing. So here we got some sample data, and depending upon this sample data, we'll try to analyze this CPCPK and PPPPK, and depending upon the results, we can comment something on the process. And I'll be taking the specification limits. Let's say this is the yield data. So total 30 batches data I have taken, and the specification limit is 70 to 120 kg. So the upper specification limit is going to be 120 kg, and the lower specification limit is going to be 70 kg. Okay. And now, to estimate these indices, we should understand the formula, or we should know the formula for this. I'll mention this. So CP, it's nothing but the upper specification limit minus lower specification limit divided by 6 times the standard deviation. Okay, and coming to PP, this is the same, upper specification limit minus lower specification limit divided by 6 times the standard deviation. So here the capital S refers to the sample standard deviation. Why? Because CP and CPK, so we are going to use only the sample data. Okay, and now let's come to this sigma. So the sigma is nothing but a population standard deviation. Okay, and now let's see the formulas for CPK and PPK. So CPK means it is a minimum value of CPU and CPL. So what does this CPU and CPL means? So CPU is nothing but the upper specification limit minus sample mean divided by 3 times the sample standard deviation, and CPL means it's a sample mean minus lower specification limit divided by 3 times the sample standard deviation. So here small x means sample mean. Similarly for PPK, it is the minimum of PPU and PPL. PPU. So it is also having the same formula, upper specification limit minus the population mean divided by 3 times to the standard deviation of population, and PPL means the population mean minus lower specification limit divided by 3 times the population standard deviation. So capital X means population mean. So these are the formulas, and here I got a sample data. So as I got sample data, so I'll be taking only Cp and Cpk. If I got a population data, that means all the data points or all the yields of a particular product, then I should go with a Pp Ppk. Here I got only sample of 30 batches, so I'll be taking or I'll be preferring only the Cp and Cpk. So Cp is nothing but the upper specification limit minus lower specification limit. So upper minus lower specification limit divided by 6 times the sample standard deviation. So I will be using the formula here, the standard deviation for the sample. So it is almost 0.93. or 0.94. And now let's come to the CPK. So for calculating the CPK, so we should first of all calculate the CPU and CPL. CPU and CPL. So CPU is nothing but the upper specification limit minus sample mean. So it's nothing but an average of this divided by 3 times of the standard deviation of sample, STD EV. Okay. So this is approx 1.03. And coming to the CPL, so this is the sample mean, that is nothing but an average of minus the lower specification limit divided by 3 times of standard deviation. So it is almost 0.85. Okay. Now the CPK is nothing but a minimum of CPU and CPL. So it is 0.85. So the CP is 0.94 and CPK is 0.85. And now we got the values, and based on this value we need to comment something on the process capability. So whether the process is capable or not, that we need to comment. So if you are able to see, the CP is going to be less than 1 here. So if CP is less than 1, then process is not capable. That means you are having multiple rejections. And also it is going to say that, so each and every time you cannot get the data points within the range. Why? Because the standard deviation is going to be high here for this data points. Okay. And if CP is greater than 1, then process is capable, and there will be certain other conditions also that we will see later. Okay. And now here we got a CPK value. So if the process is capable, if you are going to determine the process capability data based on the CP itself, then no need to bother about CPK. Why? Because here in this case the CP value itself is less than 1. So automatically the process is not capable. If the data points are not coming within the range, then why should we think about the centering? So no need to think about the centering. If all the data points or majority of the data points are coming within the specification limits, then we should think about the centering. So here in this case there are multiple rejections. So So as these are multiple rejections, so automatically no need to interpret the CPK value. However, if you want to interpret the CPK value, let's say if CPK value is less than 1, there is no centering. If CPK is between 1 to 1.33, so there is appropriate centering. And if CPK value is between 1.33 to 1.67, so centering is good. If CPK is between 1.67 to 2, so process is highly robust. Why? Because you are going to get always at a center point in the sense, so here you got a yield range of 70 to 120, and the average is going to be 95. If the centering is good, what happens is the data points or the output yield of a process is going to be reported near to 95. Either it can be like 90 to 100 or somewhere. That why? Because the centering is increased, so automatically you should get near to the standard ranges. And if CPK is greater than 2, it's a world-class process. Okay, and now let's try to have some correlation between the CPK and the sigma levels. So sigma level equals to 3 times the CPK. Okay, let's say CPK and sigma level. So if CPK is 1, 1.33, 1.67 and 2, so into 3, so from this you can see if CPK is 1, so the sigma level is 3. If CPK is 1.33, the sigma level is 4. If CPK is 1.67, the sigma level is 5. If CPK equals to 2, the sigma level is 6. So you can check these graphs and you can correlate. So if it's a 3 sigma process, there are certain rejections, but majority of the data is available within the specification limits. If it's a 4 sigma, so there are few rejections, very few, and also the centering is increased. If it's a 5 sigma, there are no rejections and the centering is good. And coming to 6 sigma, the centering is very good. That means this is the standard data, I mean the standard point, and you will be getting the outputs near to the standard ranges. So this is going to be the world-class process. Okay, so this is how you should interpret the results. And here in this case, if you are able to see, the CP is 0.94 and CPK is 0.85. Oh, let's do one thing here. As per the specification limits, the center point is 95. I'll try to do one thing. The data points which are lying apart from 75, I'll try to correct those values. So here it is. Let's start with 77. Instead of 77, I'll try to make it as 87. Now let's see, from 0.94 it has increased to 0.99, and also the CPK value increased from 0.85 to 0.90, and we'll try to correct this 76 to somewhere around 86. Now let's see, the CPK has increased up to 1.05 and the CPK from 0.90 to 0.98. Why? Because here we are not doing anything, but we are reducing the variations from point to point. With just reducing the variations, the CP and CPK is going to increase. And now this 80, let's make it to 85. Now see, further increased. So this 79, let's make it as 89. Okay, it's further increased. So now on the lower side we have corrected. Let's try to correct on the higher side now. that means above 100. The data points which are above 100 will try to correct. Here we got 110, so let's make it 100. Now see how it has increased, and this let's make it 101, further increased. So this is how these values are going to vary. And also we can do one more thing, that is varying these ranges like the 120 and 70. Why? Because the average is going to be somewhere around 90. Instead of doing that, I'll make this as 75 and I'll make this as 110. So changes are there. I'll make this as 105. Things are going back. Let's find the average of this first. Average of the data points. So it is around 93.3. So what I'm going to do is I'm going to take it as 93.3 plus or minus I'll take around 15. So instead of having 95 plus or minus 25, I'll try to make it as 93.3 plus or minus 15, or 93.3 plus or minus 25. I'll make, like, instead of having the center at 95, I'll make the center as 93.3, and now the upper specification limit is 93.3 plus 25, so it is 118.3, and on the lower side it is 93.3 minus 25, 68.3. Let's change it now, 118.3 and 68.3. Now see this, the CP and CPK has increased. So usually we are going to propose, like we are going to propose certain yield revisions depending upon the data. So this is how we need to revise the yield ranges by analyzing the current data. And also if you want to ever increase the CPK, just try to change the standard range. So previously it is around 70 to 120 and the standard is 95, and now what I have done is I have modified the standard from 95 to 93.3. so now let's see this here, the CP has increased as well as the CPK also increased. Okay, so this is how we have to estimate these indices, and we have to propose certain changes with respect to statistical analysis. Okay, so previously the sigma level is almost like the CPK is 0.84, the sigma level is 2.52, and now the sigma level is 3.84, so it's almost 4 sigma. So previously it's 2.5 sigma and now we have increased up to 4 sigma. Okay, so this is how we should understand, we should evaluate the process capability depending upon this CP, CPK and PP, PPK. So here I have done for a sample data, and if you are having any type of access to SAP, and if you are able to collect the data from SAP, like the total batches, the population data of any product, just try to perform the same analysis using PP and PPK so that you can understand better about these indices. So if you have any questions on this particular video, so you can write a mail to pharmacalci823@gmail.com. okay, and I'll be attaching this Excel sheet to our video, and please check the link in the description. Okay, so if you like the video, please subscribe to our channel and also share this with your dear ones. So thanks for watching our video.